So okay, the main problem is that I have not started recording the screen. So this this question will again need to repeat it. Okay. Let me brief these two question again. So just for this recording purpose, because I forget to record the whole thing. So you can just ignore, like, or you can let me give another 10 minutes. I will just recall this all these two questions, and again after that we will start with the new questions. Okay, so just hold on for another 10 minutes. Actually, this is my bad, I forget to start the recording. Okay, so the question previously we discussed is so the question we started with this question only. So the question is that, like, consider the sentence Ramesh scored a brilliant century, and the question they are asking, what is the type of the following relation? So century to billion. Now to answer this kind of a question, so first we need to draw the dependency structure of this sentence. So let's draw the dependency structure of Ramesh scored a brilliant century. So let's do it. So we already did it here. So Ramesh scored a brilliant century. If you draw the dependency structure, it will be, so this scored is the root kind of thing here. So, and this Ramesh is the subject and century is the object, and this brilliant just a modifier for this century thing, and A is the determiner of this century. So this is the whole dependency thing. Now for each of this this kind of arc, so this each of this dependency arc, so two kind of relation is possible. One is exocentric and one is endocentric. So what is exocentric relation? So exocentric relation is like that. So from a verb to a object or verb to a subject. Okay. So if so where this dependent part is like compulsory. If without this dependent part this relation means nothing. So just for, if you take this example for example, like score, like if you see the see this kind of relation, score to century, it's a if you see there is a path between score to century, and it's the object. So this is the century is the object for this scored part. Now in this dependency thing, if you just delete this century part, okay, if you just delete this century part, this dependency is means nothing. So the sentence will be like Ramesh scored a brilliant, then what? This is nothing. So without this object, so this without this object thing, this dependency means nothing. So this kind of relation from a root to a child, or whatever you can say, so from this kind of dependency, so where dependent is very much compulsory, so this kind of relation is called exocentric relation. So this kind of relation is called exocentric relation. Similarly, from this kind of, from this verb to subject, from this verb to subject, similarly this kind of relation also is a exocentric relation, because without the subject this verb is nothing. So the meaning of this sentence is not the same without this subject and object. So this kind of relation, this kind of dependency is a exocentric relation. Now if you just check the dependency for century and brilliant, yes, there is a dependency between century and brilliant. Okay, so century and brilliant, so it's a kind of a modifier. So now if you think of so if you just delete this brilliant part, so what will be the sentence then? The Ramesh scored a century. So Ramesh scored a century. Now, so what is the difference between Ramesh scored a century and Ramesh scored a brilliant century? The meaning is more or less same. Okay, so the meaning is more or less same. This brilliant part is just like the modifying the meaning of the sentence further, but the surface meaning is same. Okay, without this brilliant part, the sentence will be more, we got the meaning of the sentence. Okay, so this kind of thing, so this kind of a relation is called endocentric relation, where this dependent is not that necessary. So if it is there, it is fine, but if it is not there, then still it's okay. So it's not changing the structure, the meaning of the sentence. Okay, so this is the thing. So this kind of a subject, verb to object or verb to subject, this kind of relations are like exocentric relation. And if you see this kind of thing, so like from a verb to verb modifier, or a noun to some kind of attribute of this noun modifier. Okay, so this kind of, this kind of a thing is a androcentric relation, where the relation, this dependency is not that important. Okay. So in our question, so this century to billion is a androcentric relation. Okay. Now if if they have asked you to get the relation between scored and century, or scored or Ramesh, it will be exocentric relation. It will be exocentric relation if they are asked to get the relation between scored and Ramesh, or scored to century. So they are exocentric relation, and for century to billion, this is androcentric relation. That part is clear. Now the next part that we have discussed is like about this arc-agar parsing. So what they are asking is, they give a sentence and they tell you to parse the sentence using arc-agar parsing, and you need to calculate the number of time you take this action. So right arc, left arc, reduce and shift. Okay. So for this thing, we already done the example. So this is the sentence. So I prefer NPTEL courses. Okay. And the number. So what are the different operations that you can perform? It's right arc, left arc, reduce and shift. And this is the dependency structure of this sentence. So I prefer NPTEL courses. So yeah. So prefer is the root, and I is the subject, course is the object, and this NPTEL is just a modifier for this course thing. So what kind of course I like? I like NPTEL courses. So here you can see. So this prefer and NPTEL kind of like for this kind of thing. So this prefer and course is a exocentric relation, because this is quite necessary. So this is quite necessary, but this course and NPTEL kind of thing is kind of androcentric. Okay. Now the question they are asking is how to like after you have parsed this sentence using arc-agar parsing. So how many times you just take right arc, left arc, reduce and shift. Okay. So and before that, if you don't know how to parse a sentence, you can use, like, there are lots of this kind of library, like online APIs are available. So you can just put your sentence and see. So I already discussed. So there is a page called Core NLP, which is, I hope it is hosted by Stanford. You can just write your sentence here, and you can just submit, and you will get the dependency, this part of space tagging, all these things. So you can just play with these things. So these are like very much fun. So you can do it for other language also, but I hope so. Yeah. Now, suppose you already have this kind of dependency structure. Now, if we go with this arc-agar parsing, how to do? So in the arc-agar parsing, there are three things you need to remember. So one thing is like stack, then buffer, then different arc, and the action that you need to perform. So at the beginning of this parsing, so you don't have anything in your stack, so your stack is empty. And your buffer is the full sentence. So I have just written it as a full sentence. So basically it's the I prefer NPTEL course would be here. But yeah, for like conveniency, I'm just writing a full sentence. And at the beginning there is no arc in your arc set, and the action is no action. Now let's start. So if you start, so the only action you can perform is shift. Okay, without anything in your stack, you cannot do any operation. So to get anything into your stack, so only option you have you can need to do is shift. Okay, so the first operation you can do is shift. So if you do the shift, then the first character from your first word from your buffer will go into stack. So I will be in your stack, then prefer NPTEL courses will be in your buffer, and your arc is still empty. The operation is shift. Okay. Now in the next step, so you are here. So what can you, so now let's check. So from top of your stack and top of your buffer, is there any relation between them? So from top of your stack and from the top of your buffer, is there any relation? So if you see your dependency structure, you can see, okay, yeah, so there is a relation between I and prefer. And what is the relation? And what kind of relation is that? It is from buffer to stack, because it is preferred to I. It is preferred to I. So it is a buffer to stack. So it's a buffer to stack. It's a left arc relation. Okay. So it's a left arc relation. So you can take a left arc. Okay. So we take a left arc. We add the arc here. So I to prefer, and this stack will be empty then. So because after left arc operation, stack will be, the top of the stack will be removed. So I will be removed, and the buffer will be as it is, like same as it is. So now again, after you are here, again your stack is empty, you cannot do anything. So next operation you need to do is again a shift operation. Okay. So you will do the shift operation. So you will, after doing the shift operation, prefer will be here. Prefer will be top of your stack, and the buffer will contain NPTEL courses. Okay, so buffer will contain only two things, NPTEL courses. Okay. Okay, so now you are here. Now let's check if you can do anything else. So from top of your stack, from top of your buffer, there are no relations. So if you check the sentence, so prefer to NPTEL, there are no direct connection. So you cannot do anything. So only option you can do is that you can do another shift. Okay. So you will do another shift. So if you do the shift, so this NPTEL will go to here. So now this NPTEL will be your top of the stack, and the buffer will remain only one word. Most of the things are same. So you are now here. Now what you can do is that, okay, so now let's check. So what is your what is the word in your top of the stack? Okay, just hold on a minute, someone is calling me. Just hold on. Hello. Oh, sorry. Okay, so where are you? Okay, so we are here. So prefer NPTEL. So now if you see the top of the stack is NPTEL, and the buffer is course. So is there any relation between top of the stack with course? If you see our sentence, is there is a relation between NPTEL and course, and what is the relation? So it is from course to NPTEL, from course to NPTEL. So basically it's from buffer to stack. It's buffer to stack. So it's a left arc. Okay, so it's a left arc. So let's take the left arc. Okay, so we have taken the left arc. So if you take the left arc, this top of the stack will be removed. So top of the stack will be removed. So NPTEL will be removed. So now we have here. So we have prefer, in the buffer we have courses, and we have added the action that we have taken. So from NPTEL to course, it's a left arc. Okay, now we are here. Now top of the stack has prefer, and the buffer has only one word, which is course. So is there any relation between prefer and course? Now if you see our sentence, you can see, okay, so prefer to course, there is a direct relation. So there is a direct relation from prefer to course. Now what kind of relation is that? Prefer to course. So prefer to course is like from stack to buffer, from stack to buffer. So prefer to course. So stack to buffer. So it's a right arc relation. So it's a right arc relation. Okay. So we have just write it here. From here we just write it here. So if you take the right arc, so we have taken the right arc. So if you take the right arc, we have added the arc here, and so if you take the right arc, so the this buffer will again go into the stack, and this buffer will be empty. So this course, so the course part will be in the stack. So this course is in the stack, and the buffer is empty. Yeah. Now you are here. So what is your situation? So we have something in your stack, your buffer is empty, and that's all. Now what is the terminating condition of this arc-agar parsing? The thing is that if your buffer is empty, you need to stop. Now you can see the buffer is empty, so we will stop here. Okay, so we will stop here. So this is our action. So the actions that we have taken sequentially is that, like, first we take shift, then left arc, again shift, then left arc, and at the last we take the right arc. Okay, so if, and now in the question what they are asking, so in the question what they are asking ki how many times you have taken each of these actions. Okay, so let's count it here. So we have already counted here. So shift, if you see shift, how many times we have taken the shift operation? 1, 2, 3. So 3 times. Left arc twice. So 1, 2, twice. Right arc just once. So here only. So and the reduce. So there are no reduce operations. Okay. So this is the count: 3, 2, 1, 0 for shift, left arc, right arc, and reduce. But in the question they are asking in this format. So the first is right arc, then left arc, then reduce, and then shift. Okay. So if you just form this in this format, so you will find this 1, 2, 0, 3. So right arc at the beginning. So right arc at the beginning, then left arc. Okay. Then reduce, and then shift. So this is the format. So 1, 2, 0, 3. Now if you see in the example, I hope 1, 2, 0, 3 is the number 3 is the correct answer. So number 3 is the correct answer. And the question, just continuation of the question is that, like, same thing. So they are asking, so what is the sequence of operation that you have taken? So we already devise it. So the first is shift, then left arc, shift, left arc, and right arc. Just match which is the match with this thing. So I think the first one will match. Okay, so shift, left arc, shift, left arc, right arc. Okay, so the option A will be the correct answer for this question. Let me check. This is questions. Yeah. So option is the correct answer. So that part only we have discussed. So I hope this is clear. So now let's move to the next question. Okay, so what is the next question? So next question is related to this MST parser, the maximum spanning tree parser for dependency thing. So in the question what they are asking is, suppose you are training MST parser for dependency and the sentence is I like online examination, or I like online exam, and the POS tags are also given. So basically you already know. So I will be a pronoun, so like is a verb. So all these things are already given. Now simplicity, for simplicity purposes, they have said the only one relation. So basically it's mean nothing. So here, because you will, so only the thing is important here is that, so every arc from word WI to WJ, your feature, so there are features, U feature may be simplified. So they have given 4 features here, and for each of this feature they give you the weights. So this is the preliminary weights. Okay. Now what they are saying, okay, so there is a thing. Now they are saying, okay, so you have done this thing. So after the first iteration of your this MST parsing thing, and after applying the Chu-Liu-Edmonds algorithm, so I hope you already know this algorithm, because in the lecture Professor Pawan Goyal already discussed this very elaborately. So I don't need to go into this thing. So I'll just solve this question. So yeah, so they are saying these features are given, the weights are given. So after applying this Chu-Liu-Edmonds algorithm, you will get the parse tree like this. Now they are asking what will be the weights after this iteration. Okay. So if you remember the algorithm correctly, in that algorithm what we will do, so first if they give some features, then they will give some preliminary weights for each of these features. So we'll just need to okay, so after this feature and weights are given, we will calculate the edge weights, and accordingly after that we will using this Edmonds algorithm, we will first draw the first MST parse or dependency tree of the sentence, and then we will match with the dependency thing with our gold dependency parser, and accordingly we will update the weights. So that is the whole thing. So now they are asking ki after the first iteration what will be the weights. Okay, so if the preliminary weights is 5, 20, 15, 12, so what will be the what will be the weights after the first iteration? Okay, so let's do it together. So okay, let's do it together. So what is the sentence? The sentence is I like online. And after one iteration, what is the parse tree that you have got after MST? Is after MST and this Edmond Chu-Liu algorithm. So I'm just writing this algo. So what is the tree that you have got? It is they already given. So it is root to like to I to online, online to exam. Okay. So it's a this kind of thing. So root to like, then like to I to online, and then online to. So this is the after first iteration, after using this Edmond Chu-Liu algorithm. So Chu-Liu algorithm, you get this. This is the first parse tree, dependency tree of this MST tree of this sentence. Now, what is the actual parse tree? So, what is the actual parse tree? So, if you see it correctly, the actual parse tree is quite simple. So, basically, root will be there. So, basically, what is the root? Root is the verb. So, okay, like is the root. Okay. Then like will be connected to I, and also like will be connected to exam, and then exam is connected to online. So this is your gold parse. Okay, this is given. So this is after first iteration. This is after so after using this thing after first iteration. So they have given this thing, and this is the gold thing. So you can deduce the gold thing because you know. So this is the root is the verb, and this is the subject of this root, this is the object of this root, and this online part is just a modifier for this exam. So this is the gold. Okay, now there are few features are there. So let's calculate the features for each of this individual node, individual edges. Okay, so the features are there. Let's calculate the features. Okay, so first calculate the feature for the given graph. Okay, so for each of this edge I will calculate the feature. Okay, so there are 4 features. So F1, F2, F3, and F4. Okay, F1, F2, F3, F4. For each of these things we will calculate. For this one also we will calculate. For this one also we will calculate. So this is the thing. So F1, F2, F3. Similarly, F1, F2, F3, F4. Okay, now let's put the value here. So first, what is the first feature? First feature is that POS, like the WI is the head part. So if you have a directed edge from WI to WJ, so WI is the head and WJ is the WI is the source node and WJ is the target node. So this is the thing. So WI is the source. So what is the first feature? First feature is that WI would be a verb and the WJ would be a pronoun, noun or pronoun. Okay. Okay, so it will be a noun or a pronoun. Okay. So it will be a noun and pronoun. Okay. So what is the let us write it here, so it will be easy for us. So for F1, wi would be a verb, and wj would be a noun or pronoun. Okay, so let's check it here. So yeah, so it's a wi is a verb, wj is a noun and pronoun. Okay. Now just fill the value. Okay, so for this age, so what is the wi? For this age, wi is root. Okay, so wi is root. So root is not corresponding to any POS tag. So obviously this is 0. Okay, this is 0 because like root don't have any POS tag. So it is okay. So first fill up all the F1 value for all these ages. Okay. So for let's check for this age, like to I. Is like is a verb? Yeah. So like is a verb. So first condition is true, and the second condition is that wj is a noun or pronoun. Is it a noun or pronoun? I is a pronoun. Okay. So I is a pronoun. So it's meets the condition. So okay. So like to I. So this meets the condition. So the wi is a verb, wj is a pronoun. So we'll just write it 1 here. Similarly for the second age, so I to online. So is I is a verb? Is I a verb? No. So I is a pronoun. But in our feature, so I should be a verb. So it is 0. Now for this online exam thing, is online a verb? No. Online is just a noun or noun modifier kind of. You can see it's kind of a yeah, so just a kind of a adjective kind of thing. But in the question they are saying this is a proper noun. So they are saying online is a proper noun. No, whatever. So basically the point is that this is not a verb. Okay. So again, so this is also will be 0. Let's calculate for our gold ages also. Okay. So let's calculate for our gold age also. F1, F2, F3, F4. For this is also. So I am doing it elaborately, just if such a way so you don't have any confusion after this example for this kind of question. Okay, so let's do it. Okay, so for root to like, say some root is not a verb, so it will be 0. Okay, so like to exam, yeah, so like is a verb and exam is yeah, so like exam is a noun, so it will be, so it will be 1. Okay, so like to exam will be again 1. For exam to online, exam is not a verb, so it will be 0. Similarly for like to I, like is a verb, I is a pronoun, so it will be 1. So the feature 1 calculation is over. Now let's go to the feature 2. So what is the feature 2? Feature 2 is that wi is a root or wi occurs before wj. So what is the feature 2? Feature wi is a root. So this is the feature 1. So feature 2 is that wi is a root or wi occurs before wj in the sentence. So this is the feature. So yeah, so wi before wj in the sentence. Now let's fill all the values. So first with this one, so root to like. So root to like, yeah. So obviously this is the OR condition. So any one of the condition is fulfilled, then this feature will be 1. So wi is root. Yeah. So root to I. So obviously wi is root. So obviously it is fulfilled. So F2 is 1. Similarly for here also, F2 will be 1. Now for other things, so like to I, so obviously the wi is not a root, but let us check for the second condition. So is wi occurs before wj in the sentence? So basically what the question is, so is like occur before I in the sentence? No, because like occur after I. Okay, so it's not fulfilling. So it's not fulfilling. So here, so like occur before I. So yeah, so like occur after I. So like occur after I in the actual sentence, but in the feature they are saying ki wi occurs before wj. So obviously this will be 0. Now let's check I to online. I to online, yeah, this will be true because I is occurring before online in the actual exam, actual sentence. So it will be again 1. For online to exam, yes, again 1 because online occurred before exam. Okay, so this part is good. So okay, so if let you also check it, so maybe somewhere I can make some mistakes, so just check it. Okay, for now let's check for the goal thing. So this like to exam thing, so like to exam again, this will be 1 because like occurs before exam in the actual sentence, so it will be again 1. Exam to online, this will be false because exam occurs after online. And like to I, this is also false. This is also false because like occur after I. So the feature 2 calculation is also over. Now let's check for feature 3. Okay. So what is the feature 3? Feature 3 is the wi is root and pos of wj is verb. Okay. So wi is root and wj pos of wj is verb. So this is the, so wi is root and pos of wj is verb. Okay. Now let's check. So if you see the condition only, so this is the AND condition, so only root. So in the, so in those, only those dependency will give 1 where root is present. Okay, so where root is present and the wj is, the pos of wj is verb. So let's check. So root, here the root is wi is root, it is fine, and wj is like, so it is verb, so it is 1. Okay, but for other dependency, root is not there, so obviously we don't need to check the second part. Okay, so it will be again all be 0. Again for this also it will be 1, but for other cases it will be 0. So F3 is also over. Now let's check the last feature. So what is the last feature? So the last feature is wj occurs before wa in the sentence. So it is the reverse. So F4, wj occurs before wi in the sentence. So this is the feature 4. Now let's fill up. So obviously this wi is a root, so is don't have any presence in the actual sentence, so it will be 0. Similarly, it is also be 0. Now for like to I. So like to I, is I occur before like. So if you check this, so wj occurs before wi. So wj, so this I occurred before like, no. Yeah, it is true. So it is true because like occur before I, so it will be 1. So it will be 1. Okay. So here also it will be 1. Now for I to online, so is online occur before I? No, this will be false. And for online to exam, so is exam occur before online? No, it will be false. Similarly here also, like to exam, is exam occur before like? No, it will be false. And exam to online, is online occur before exam? Yeah, it will be true. So we have calculated all the features for all these edges. Now what is the step? So what is the step? So just remove this. Okay. Now what is the next step? Next step is to get the difference between. So yeah, so if you see the question, so in the question you can see, so the preliminary weights are given. Now you need to just update the weights. So what is the formula to update the weights? So the new weights will be, so this is the old weight, so write it old. So it will be plus the gold features minus the first iteration that you got after the first iteration thing. So this is the formula. So so you just need to add the difference of gold minus the thing that you have get after your ECL, like Edmond-Chuli algorithm. So then you need to add with the old weight. That will give you the new weights. So this is the formula. Okay, so just now subtract from gold to this the thing that you have get after the first iteration. Okay. So if you have just checked, so what is the total sum of this gold thing? So if you just check, we don't need to sum all these things, because if you see this root to like and this like to I is common for both of these things. So root to like and like to I is common. So we can ignore those things. So only we need to add the other edges. So if you just take this edge and this edge, so if you just take, so the weight of this thing 1 1 0 1 and this is 0 0 0 1. So the total weight of this is 1 1 0 1. Okay, so it is 1 1 0 1, and what will be here? This is this z. So this part is already taken care of. Just this one and this one. Okay, so this will be 0 1 0 0 and 0 1 0 0. It will be 0 2 0 0. So it will be 0 2 0 0. Now just subtract 1 1 0 1 minus 0 2 0 0. So just if you just do the element wise difference, so it will be 1 minus 1 0 1. So this is the difference. So this is the difference. Now you just need to add this thing with your given weight. So which is 5 20 15 12. So it is 5 20 15 12, and what we have gotten, it is 1 minus 1 0. So it will be 6 19 15 30. Okay. So this is the answer. So is it clear to everyone? If you check the answer, so it is 6 19 so 6 19, what the answer that we have get? 6 19 15 13. 6 19 15. Yeah, no, option 2 is the answer. So is it clear to everyone? If not, they can say. Did you get it, or again I need to tell? Okay, so yeah, so there's got it. Okay, so if you already understand that thing, so let's go to the next question. Okay, so let's go to the next question. So what is the question is that it is related to this data driven deterministic parsing. Okay, so in this question what they are saying ki, you already have a sentence, I prefer NPTEL course is a gold standard parse in your training data, and you are also given, so all these POS tags are there given there. So what are the different things they have also said ki, okay, so they have given 4 features. So there are 4 features, this 1 2 3 4, and each of this feature will stick with the different actions. So what are the different actions? You already decide ki left arc, right arc, shift and reduce. So there are 4 features and 4 actions. So there, in total there will be 4 into 4, that is 16 configurations different with configuration. So that's why they are giving you the 16 weights. Okay. So that's why they are giving you the 16 weights. So the first part, the first 4 are related to the left arc, and for left arc and for each of these features, the first 4. The second 4 is for right arc and these 4 features. So and for the others are for this shift and reduce. Now what they are saying ki, okay, so use this gold standard parse during online learning, and what will be the weights after completing 2 iteration of the arc parsing over the sentence. Okay, so they are saying ki we have this the parser and the initial weights are given. So what will be the weights after the 2 iteration of this arc parsing? So the initial loads are given. So what will be the weight for the next step? Okay, so let's do it. So the again the sentences are same. So the I prefer NPTEL course. Sorry, NPTEL course. Now you already know the dependency structure of this thing. So basically, this is there, this is there, and this course is related to this. So this is the structure. So this is the subject, this is the object, this is the noun modifier. This is the structure. Now, so what the thing they are asking ki, let's do two step of iteration and update the weights, the initial weights. Okay, so let's do it. So let's do it each of the steps. Okay, so in the first step, so the initial step, what is the initial step? So in the initial step, so this is the stack, this is the buffer, this is the arc, and this is the action. So the initially stack is empty, buffer is the full sentence, and arc is also empty, and no action is there. No action. So action is there. So this is the zero iteration. You can say this is a 0th iteration. So we are not calculating this thing. So this is a 0th iteration. Now let's start. Okay. Now obviously, if the stack is empty, then the action that we need to take is that shift. There are no other options. So shift. If we take shift option, so it will be then I. So in the stack, it will be I here, and the sentence in the buffer, it will be prefer, then dot. Then arc, there is no arc empty. This is the first iteration. Now let's calculate the weights. So after this first iteration, let's calculate the weight. Okay. So yeah. So how to calculate the weights? So this is our this is the gold. This is the gold action. Okay. So this is the gold action after the first iteration. So this is the gold action. Okay. Now if we go with the feature kind of formula, so what should be your first iteration action? Okay. So if you see if you see your this kind of thing, so there are features, 4 features are there. So let's so I'm just writing it here. I will delete it. Okay. So for each of this action, so left arc, right arc, reduce and shift. So all these things, so there are four features, F2, F3. So there are 4 features. Let's calculate the features. So for each of this feature, what will be the value, 1 or 0? Okay. So what is the first feature? Stack is empty. Okay. The stack is empty. So stack is empty. It is true for all these actions. Okay. Because stack in the first iteration, if you start with the first iteration, the stack is empty. Okay. So this is after the first iteration. This is the after the first iteration. So at the beginning, so the stack is empty. So it is true for all these actions. So if you take right arc, left arc, reduce or shift, it is true for all these actions. Okay. Now check for the other features. Now for all these features, there are constants. So top of the stack is noun, top of the stack is pronoun, or top of the stack is something like that. But in the beginning, there is no thing in the top of the stack. Okay. So for all these features, the value will be 0 for all these actions, because there is no thing in the top of the stack. So irrespective of the actions, this value will be 0. Okay. Now what are the weights for all these actions? Now what are the weights for all these actions? If you check, the weights are 2, 2, 2 for right for this left arc. So all these are 2 for left arc. So it is 2, 2, 2, 2 for right arc. It is 3, 3, 3, 2. It is for right arc it is 3, 3, 3, 2, and for all these others it is I guess it is 2, 2, 2, 2, 2, 2, 2, 2. So yeah, if you just check, it is, yeah, for all this thing is this 2. So this is the initial weight. So this is the initial weight. Now then if you just multiply this dot product, so what is the value for left arc? So what is the value for left arc? So all these are 0, so only the first thing is there. So if you just multiply dot product wise multiplication is there, so then it will be 2. Similarly it will be 3, it will be 2, it will be 2. So this is the weights, this is the votes for after first iteration. This is the vote for first iteration's action. So this is the vote for first iteration action. So what is the maximum value? Maximum value is 3. And what action it is corresponding to? It is corresponding to right arc. Okay. So as per the algorithm, so they are saying ki take right arc. So they are saying ki take right arc as per the algorithm. So as per the algo, so they are saying ki take the right arc. But as per this dependency parsing, like goal dependency parsing thing, so the right action is shift. Okay, so the right action is shift. So that's why I have written it is a gold action. But as per the algo, you should take right arc at the first iteration. Okay, so this is the thing. So you just need to update the weight. So what is the formula? Formula is like W old plus like the correct thing. So the correct thing is I am just writing the configuration 1. So in the first step is I am just writing configuration 1. The shift is the correct operation, but in the configuration 1 you are saying the right arc is there. So you just need to uh, like, yeah. So you just need to subtract this the wrong thing. So just add the gold thing and just subtract the this algorithm given thing with, and it will give you the new weights. So I hope you understand. So the gold action as per your dependency parse is shift, but as per the algorithm, your they are saying कि right arc is the correct thing. So you just need to update the weights. So if you just update the weights, so if you see, so only shift and reduce weights will be updated, but this but this left arc and reduce will be remain same. Okay. So what is the thing? So yeah. So yeah. So let's do it. If you just write it all the weights sequentially, it will be here. So for one iteration I'm just writing, so it's very difficult to write it for all these things. So yeah. So write it like this way. So let's do it as per their convention. It will be easier for them to check the answer. So left arc, right arc, shift and reduce. Okay. Left arc, right arc, shift and so shift and reduce. So reduce is at the end. So what is the gold? So what is the old thing? So old thing is 2 2 2 2. This is for left arc. Then for right arc it is 3 3 3 2. Okay, so this is W1, and then shift is 2 2 2 2, and reduce is again 2 2 2 2. Okay. Now what is this FC1 shift? So basically in the shift operation, so this is the FC1 shift. So in the shift thing, this is the shift thing. In the first, this is the only one. So in the shift thing, so all others value will be 0. Only shift. So this shift part will be there. So 1 0 0 0. So it will be 1 0 0 0, and again this part will be 0. And what is if C1 right arc? Again, so this left arc will be 0. Right arc part is 1 0 0 0 1 0 0 0, and this thing again 0. Okay, so basically you just need to add these two and then subtract this. So this will give you the updated weight. This will give you the updated weight after first iteration. So it will give you the updated weight after first iteration. So what will be the updated weight if you just do? So this thing, so this part will be remain same. Okay, so I'm just writing the W new here. Okay. So for LA, it will be remain same. It will be 2 2 2 2. For right arc, it will be you can see, so this 2 will be added and this will be subtracted. It will be then, so 3 minus 1 will be 2. So 2 3 3 2. Then shift will be this will be added, so 2 plus 1 will be added, so it will be 3 2 2 2, and then reduce will be same, so it will be 2 2 2. So this is the weight after first iteration. So this is after first iteration. Now they are, so in the question they are saying ki, so do another iteration and then report the answer. So okay, so we can do it another iteration and then report the answer, but the process will be again lengthy. So let's do it for this question, so just to make the confidence. So I'm just removing this thing, so because these things are not needed now. So okay, so what will be the next iteration? So in the next iteration, what should we do? So top of the stack is I, top of the stack is I, but in the buffer we have prefer. So now let's check what is the relation from stack, top of the stack with the top of the buffer. So if you see the gold parsing, so there is a relation from prefer to I and prefer to I. So basically from buffer to stack. So from buffer to stack. Now from buffer to stack, obviously it's a left turn. So it's a left turn. So we can take the left turn. So this is the action we need to take. It's a left turn from buffer to stack. Okay. So as this is a left turn, so again the stack will be empty. The buffer will be remain as it is, and we need to add the this R in R. So this is the after second iteration. Now after second iteration, what is the goal relation? So goal in the second iteration, this is the goal relation as per our dependency tree. Okay. Now we need to check what is the action we need to take as per our algorithm. So again, then we need to calculate the different features for each of these actions. So what are the actions? So actions are left arc, right arc, shift, and reduce. So for each of this action, we need to check the function value for feature value for all these things. So it is, yeah, so left arc, right arc, shift, and reduce. Okay, so let's check the features for each of these things. So now we are here. So basically when we are calculating the second iteration, so basically we are here. So basically after taking the inputs of the first iteration, we will calculate the second iteration. So basically this is our input here. So this is after the second iteration. Okay. So we need to calculate the features from here only. So now if you see the features, here, top of the stack is empty. Top of the stack is not empty because top of the stack contains I. So for all these features, this F1 will be 0. Okay. Now what is the next feature? Next feature, top of the stack is noun and top of the buffer is verb. So top of the stack is noun. So they are thinking, but top of the stack is I, which is pronoun. So again it is 0. What is the feature? F3. Feature 3 is top of the stack is pronoun. Yes. Top of the buffer is verb. Okay. So for top of the stack is a pronoun and top of the buffer is verb. Yeah, prefer is verb and I is pronoun. So F3 is 1 for all these actions. And what is feature 4? Feature is top of the, what are the top of the stack before the what of the buffer in the sentence. Yeah. So in the feature 4 is that the top of the stack word appeared before the word top of the buffer. So basically they are saying I is occur before the prefer. So it is true because I occurred before prefer. Okay, so this is also true for all the action. So again we need to calculate the vote. So what is the what is the weight now? So this is the weight. Now we need to take this weight as the for calculation, because the initial weight is already updated by the weight. So this is 2 2 2 2, this is 2 3 3 2, this is 3 2 2 2, this is 2 2 2 2. Now we just do the dot product, you will get the value. So just add the last two things. So because last two values are 1, so it is 4, it is 5, it is 4, it is 4. So again, if you take the argmax, so this is the highest value, and the action corresponding to is right. So as per the algo, so as per algo, the correct decision should be is right arc. But as per your goal dependency structure, you know ki left arc is the correct thing. Again, so what will be the new weight? So the new weight will be, old weight plus feature of 2, so left arc, because you know the left arc is the correct thing, minus feature of configuration to right. So this will be your answer after iteration 2. So just calculate. So same thing. So it is not very difficult. Okay. So first we write the left arc thing. So 2 2 2 2. Then this is the left arc. Just one sec. This is the right arc. So which is 2 3 3 2. Then shift, which is 3 2 2 2. Then reduce, which is 2 2 2 2. Now this is the old. Okay, so this is the weight old. Now what is FC2 left arc? Okay, so if you see the left arc like this thing, so only 0 0 0 1, so only 0 0 1 1, but for other thing it will be 0. And what is your FC2 right arc? So for or other thing it is 0. For right arc it is 0 0 0 1, so it is 0 0 1 1, and for the other thing is 0. So you just then, so basically you just need to add these two and then subtract it from here. That will give you the answer. So what will be your new updated weight? So just write it here only. So the weights, so W new left arc. Okay. So what is the left arc? Just add the first two and subtract the last row. So basically it will be 2 2 3 3. And what is right arc? Right arc, yeah. So the second row is all 0, and you need to divide subtract then the last row. So it will be 2 3 2 1. And for shift it will be remain same, 3 2 2 2. And for reduce, yeah, again it will remain same, 2 2 2. So this is your new updated weights after second iteration. Okay, so if you just check the answer, you will find it. Okay, so if you just, I don't know, so if you see, so from left, right, so 2 2 2, I think number 3 answer is the correct answer. Okay, yeah, so this is the right arc, 2 3 2 1 2 3 2 1 2 3. Yeah, so option 3 is the correct answer. Okay. So is it clear for this question? I tried to do it like as elaborately as possible, but if still some doubts is there, you can tell. Okay, thank you. Okay, so I hope there is only one question. Yeah. So this is the last question I want to discuss. So this is related to this algorithm, Edmonds algorithm. So this question is pretty easy, I guess. So the graph is given. The weights are given. Now they are saying you use the Chu-Liu-Elmore algorithm to find the MS tree, and which pair of the nodes will be contracted to form the single vertex during the algorithm in the first iteration. So okay, so they are saying after the first iteration which node will be contracted. Okay, so let's do the thing step by step. So we just need to do for one step only to get the answer, because they are saying after what is the answer after the first iteration. Okay. Let's do it. Okay, so if you remember this Chu-Liu-Elmore algorithm, the first step is that we need to find the greedily we need to choose the incoming edges. We need to check the incoming edges which give us the highest edge weights. So we need to choose the incoming edges which will give us the highest edge weights. Okay. So for each of these nodes, we need to check the incoming edges, and which will give us the highest edges. So for V1, which incoming edges give us the highest edge weight? So for V2 and V3, so all these things. So and for root node, there are no incoming edges, so root will be disconnected at the beginning. Okay. So let's draw the structure. So at the first step, so root will be disconnected because there are no incoming edges. Now for V1, if you see there are 2 or 3 incoming edges. One is 5 from root to V1, 5. One is V2 V1 which is 10, and one is V3 to V1 which is 9. So among them 10 is maximum. So we will keep the this way. So it will be 10 from V2 V1. Okay, so from now V2 V1. So V1 is there, and we need to keep this to here, the weight is 10. Okay, now do for edge V2, and for V2 there are 3 incoming edges. One is from root which is 1, one is from V1 which is 11, and one is from V2 which is 8. Okay, so among them 11 is highest, so from V1 to V2 is highest, so this will be the edge. So V1 to V1 which is 11. And lastly for V3 there are again 3 edges, incoming edges. One is from this root, one is from V2 which is 5, and another is from V1 which is 4. So among them this V2 to V3 is highest, which is 5. So we'll keep this. Now if you see, so the next step is that we need to check, okay, so is there any cycle? Obviously there is a cycle. Okay, so if there is a cycle, then the step is that we need to contract this thing to one node, and again do the calculation. Okay, so after the first iteration, obviously, so this V1 and V2, these two nodes will be 1, the root will be the other node, and V3 will be the other node, and then we need to calculate the root weights for all these things. So we need to calculate the root weights from. So suppose I represent it with W1, it will be W2, and this is W3. So we need to calculate this W1, W2, W3, and again do the algorithm again. But as per the question, so we got our answer. So after the first step, we need to. So what are the nodes that we need to contract? So yeah, so V1 and V2 need to contract. So V1 and V2 need to contract because they consist a cycle. So this is the answer. So the answer 4 is the, so the say the option 4 is the answer. Okay. Yeah, so basically that's it. So if you want some more example, I can show you, but I hope this is fine. So you just do it by yourself. But if you want one or two more example, I can show you. But yeah, so as per your needs, or we can cover, like we can close it to what you want to do. So do you want me to do another one to example or similar example for this parsing thing, or we can stop?
It's okay. The thing is, what now? I do have one question. What are the examples we do have for question solving? So they're having a weightage of 1 mark only, isn't it? So in a final examination, what are the questions will be there? They will have a 1 mark weightage.
Actually, the thing is not clear to me. Basically, I cannot answer it. But the thing is that I know your point is that you are saying ki for some question which are like which is not that time consuming, you are like you are
Yes.
getting one,
So
and
what
for
are the
some
questions you are explaining? They are too much time consuming.
yeah,
And having a weightage of 1 mark
is not, yeah.
quite
I hope this is only for this assignment purpose. I think for
okay.
in the actual examination, so when they are I think the question will like carrying different marks. I hope so, because else it will not, like the thing is that, so this type of question taking too much of time and you are just getting 1 marks for that, it is not justified. So yeah.
And can we use the calculator? Because some questions are there where obviously we need the calculator.
Yeah, but I don't think so. There are many questions. Like, is there any questions for that you need calculator? But yeah,
Yes.
if so, you can use it. I don't think so. There are any hard and fast rule to don't use calculator. You can use it.
Okay. Thank you.
Thank you. Then, if you don't have any other concerns, we can stop it here. Uh, else, else we will meet in the next Tuesday. Okay, let's close it. Thank you, everyone. Bye.